All right, I wasn't totally satisfied with my explanation of voltage drop, and I wanted to give a real-life example. Theory's good, but practice is also good, and sometimes you need both for the concept really to stick. So, I'm here in the shop. I have a 12-volt power supply set at 12 volts, so this is basically like a car battery with less capacity. Got a couple wires coming down. I have a halogen headlight bulb, and when I send power and ground to it, lo and behold, I get light. So now what I'm going to do is I'm going to show you the effect that a bad wire has in the circuit. First, I'm going to show you why ohms is not a good test. Okay, so this is, I have two pieces of wire here, cut from the same. This one's just a little shorter. This one is perfect, completely intact, nothing wrong with it at all. So we're going to take an ohm measurement, or resistance measurement, and I get 0.2 ohms, okay? 0.2. Now, the leads themselves are giving me 0.3. So basically, if I were to reset this and get myself a 0, which I sometimes do, although a lot of times it's not needed, I get basically no resistance, okay? Now, I'm gonna take the resistance of this wire, which is missing, this is basically 5 or 6 strands left. I cut almost all of it away. And same result. Okay, same result. Now, in case you're wondering, yes, I have continuity. It says I have continuity and 0.2 or 0.3 ohms. So if I were to only use a multimeter with an ohms measurement, I would suspect that this circuit is fine. There's nothing that gives me a hint that this circuit is not okay. And there's a few reasons for that. The first is that this meter is using a 9-volt battery and sending power or electricity through here and measuring how much comes back. A wire's capacity to carry amperage is based on its size and based on how hot it gets. So if you have only a teeny tiny amount of amperage going through the circuit, which is true when it does this test, then you don't need very many wires to carry that amperage. But in real life, a circuit this size, a wire this big, is going to carry a lot more amps than that little 9-volt battery can put out. And so what you're doing is you're sort of just running a teeny tiny little test, and then if the teeny tiny little test passes, you assume that a big test would pass, but that's not true. That's where a voltage drop test comes in. Now, when you do an ohms test, you always do it with a dead circuit. There's no electricity in the circuit. Nothing's lit up, there's nothing turning, there's no battery hooked up, right? It's a dead circuit. When you do a voltage drop test, it's the opposite. It has to be a live circuit, otherwise it's worthless. So I'm gonna go back over here now. Now, I'm gonna be hooking these up, one to the load and one to the power supply way up there. I can't film both easily, so you just have to trust me on that. And if you don't trust me, then go watch a different YouTube video. Okay, and I'm gonna bring this in for you so you can see the measurement. Now we're gonna flip to DC volts, okay? Now, I am going to put my wire in the circuit. Actually, I'll do it the other way, where I put this in here first, like so. It's not a great connection, but it'll be just fine for this. And then I'm gonna do this, oops, and we have ourselves a bulb. Okay, I'm gonna go from the ground, basically the negative battery post, or in this case, the negative terminal of my power supply. And instead of going to the power side, which would give me 12 volts, well, roughly 12 volts, I'm gonna go to the negative side. And I'm gonna get something very close to 0.05. What that means is that as the electricity travels from here to here, I'm only losing 0.05 volts, which is great. You wouldn't want to lose much because there's nothing in the circuit that should be consuming the amperage. When I go from the positive side, I get 0.3, and that's probably because this little connection here is not that great. So I get a little bit more. Now, I'm going to disconnect this, and I'm going to insert this little guy into the circuit. Okay. Now the amazing part, in my opinion, is that the thing still works. Oops. It's actually basically trying to weld itself in there as I do this. Oh, sorry, folks. Okay, there we go. Okay, so we're still lit. Now, I'm gonna do the ground side again just to show you that it doesn't affect the ground side. So we have 0.06, same as before, because I didn't do anything to the ground side. The ground side of the circuit is still totally fine. Let me lower that. Now we're gonna do the power side. So I'm going from the positive battery post to right here. And we have 0.6, 0.5, 0.6. Okay, so what does that mean? What that means is that as the electricity travels from the positive battery post, or in this case, my power supply, I'm losing 0.6 volts somewhere. Now, of course, we know where. In a normal diagnosis, you would not know where, and that's what makes diagnosing electrical circuits difficult. Oh, and if you hit the ground side, you get a nice big spark. Let me see if I can do it here. Okay. Should have put in some clips or something, some alligator clips. Okay, there we go. Now, it means that I'm losing 0.6 volts as I travel from here to the bulb. And that's obvious because that little strand is consuming amperage because it's undersized for the circuit, or it's been corroded, that sort of thing. Now, I can further isolate everything. Tilt you back up so you can see the meter. Of course, there's a trash truck coming through. So I can now go from here up to my power supply, and all of a sudden my reading is very little. That's because I'm not losing any voltage from the power supply to here. But if I go here to here, 0.6. So what that now tells me, I'm losing voltage in between the leads, okay? In between the bulb and this alligator clip, I'm losing 0.6. And then as I go here, I'm still losing it. As I go here, I'm still losing it. So you can literally trace the wires. Of course, they're not always that easy to get to, but you can basically close in on the circuit. Now, there's a few things that I want to draw your attention to. The first thing is that taking an ohms measurement or a resistance measurement is unable to detect this type of a failure. That's number one. Number two, this is actually an extreme failure. So I have a wire which is like 95% gone, and an ohms test still couldn't find it. Even the voltage drop test only showed me that I was dropping 0.6 volts. Now there's a few reasons for that. One is that this thing is not pulling a ton of amps, and this wire is relatively beefy, so on and so forth. And so in a real automotive circuit where the wires are sized for the load to save cost and weight, the readings will probably be a little bit higher than 0.6 if you have lost 95% of a wire. The other amazing thing is that the circuit still works. That's absolutely incredible to me. It's not a surprise, it's just still incredible after all these years. Now, once the circuit gets warm and hot, like the headlamp's been on an hour or something, that voltage drop will start to go up because that little wire will get hotter. And as it's unable to dissipate the heat, it becomes less capable to carry amperage across it. The last thing I want to say, a voltage drop test always has to be done with the circuit loaded. If it's a fan, it's got to be spinning. If it's a light, it's got to be on. If it's a compressor, it's got to be churning. So you do ohms tests in a dead circuit where there's no electricity. You do voltage drop tests in a circuit where there is electricity. The last thing I want to say and explain, I'm going to need both my hands for this. Some of you may be wondering why you can't do something different, okay? Some of you may be wondering, well, James, why can't you just go from the positive to the negative side of the circuit like this? Okay, why do you always go ground to ground, power to power? Here's the reason why. We all know that batteries put out roughly 12 volts, but when an engine's running and you have alternators running, it might be 13.5, might be 14.1, might be 12.7. The voltage, excuse me,
the voltage varies. Now, the degree to which it varies also varies. You don't always know how much it varies. So the problem is, if I go up to my power supply and I read 11, see, it's fluctuating. So so my power supply is changing. Maybe it's a cheap one, I don't know. My battery voltage is changing. And so what you don't want to do is you don't want to go up to the battery and say, okay, I have 13 at the battery. Now I'm going to go to my load. How many do I have at my load? 12.6. Okay, I lost 0.4. You don't really want to do that, because by the time you went from the battery to the load, something may have changed. The alternator may have lowered its voltage output because battery's almost charged or something. So you always want to take a reading and the math is done automatically for you. You don't want to have to try and remember, you know, I had 13, now I have 12.6, that means I lost 0.4. You want the meter to do the math for you instantly, because those things do vary and change. Now, you can do one of those measurements really quick. You can see, okay, I have 13 at the battery and I only have 9 at the load, so it means I'm losing, you know, 4 volts. That's fine. That can be a first step if you like. And I like to do that because it kind of makes more sense. You know, looking at a bunch of zeros, sometimes you wonder, am I doing this right? Whereas when you see 12.6 or 13.1, you kind of know what you're getting. But you always have to do the voltage drop test live so that all of the math is taken out of it and any fluctuations don't show up as readings. So I hope that was helpful to someone. Voltage drop is an extremely important concept, and you need it to find things like this, or things that are a little worse than this, or things that are a little better than this. And I would suggest, when you're working on a 12-volt circuit, to suspect a problem whenever you have more than 0.2 volts of voltage drop on the power or on the ground. You don't want to lose more than 0.2 going from the battery to the ground. You don't want to lose more than 0.2 going from the power to the ground. There's a couple of exceptions to this, like a big fat starter cable while you're cranking, but by and large, you're going to be safe at 0.2. I hope that helps. Take care, guys. If you didn't like this video, give it a thumbs down. And I would go check out, in this case, let's see, check out Project Farm. He reviews gear and tools, very unbiased guy. I like him a lot. He doesn't do stuff like this, but if you're watching this video, you'll probably like him too. So give this a thumbs down. Go see Project Farm. Have a good day, guys.